Right. Well, let's get started then. So welcome to the webinar, Striving for the Lowest LCOE with the new 2P linked tracker design. So today we'll have two experts on trackers. Just let us know how you could drive a lowest for the lowest LCOE with these new design, and they are Miguel Pozuelo and Eduardo de San Nicolás from Soltech. Would you can you introduce yourselves briefly, please? Let's start with Miguel.
Hello, Carlos. Thank you very much for the introduction and for inviting us for this webinar. Well, my name is Miguel Pozuelo. I've been working at Soltech since 2015 in different markets in Central America and Europe. And currently, I'm key account manager for Middle East market.
Thank you, Miguel. And could you please introduce yourself briefly? And by the way, Manuel, could you stop sharing the intro screen? So there we go. Thank you. Please, Eduardo.
So thank you very much, Carlos, for the introduction. My name is Eduardo de San Nicolás. I've been working with Soltech for the last 6 years and in the solar industry for the last 15. I'm responsible for the strategy and the corporate development of Soltech.
Thank you very much, Eduardo. So if you'd like to get ready to share your screen. And in the meantime, I'd like to remind everyone that we are recording this session. You'll get a recording and the presentation slides as well on by email towards the end of the week, probably or early next week. And remember also that for those of you who joined a little bit later, that you can pose your questions using the Q&A box at the bottom of the screen. So, right, I can see the presentation, your slide, Eduardo. So over to you.
All right. So today we're going to talk about the new 2P link tracker design. But before getting into that, I would like to introduce Soltech, to dedicate a few minutes for introducing Soltech. Soltech is the third global biggest solar tracker supplier. It's the first one in Latin America, first in terms of Bifacial technology with 16 years of experience and over 1,600 people in the company. We have a track record of 11 gigawatts worldwide, and you can see in these slides a few few numbers about where we have done our projects so far and where we have worked so far. Before introducing the new tracker generation, it's important to understand where does it come from. We started with the bifacial trackers back in 2015 in the Silla project, in which I was, by the way, the project engineer. This project was important for us because it was the first one in which we introduced and designed specifically for a utility scale planned a bifacial solar tracker, one in which everything was designed for boosting the bifacial generation, the bifacial gain. This project that was in Chile in the desert of Atacama, we could achieve up to 13.3% bifacial gain with almost handcraft made panels. And right now, the panels that we can find in the market are industrial scale and way better than this one. So I guess how much we could have achieved if we had those panels in the present. It's also important to mention that even though we started in 2015 with this project of La Silla, we realized back then that the bifacial technology had a very huge potential. So in 2017, we released the SF7 tracker that was a better design or an optimized design for bifacial generation, but also incorporating the new technologies, the new research and that we had introduced in the product. So we designed this tracker you can see in the image that potentially could increase the bifacial gain up to 25% under special conditions. But we tested it in the BITEC, in the Bifacial Tracker Evaluation Center, about which I'm going to talk in a minute. And we realized that in conditions of high albedo, we could achieve up to 15.7% gain, and in comparing it to the regular monofacial 1P tracker, one panel in portrait configuration panel, we could achieve 2.1% extra gain. So this is not a simulation. These are real numbers that we have come out through 2 years of data gathering. The SF7 introduces several features special for bifacial boosting. One of them is that there's no shading, there's no interference from any element of the tracker in the backside of the panels. We leave intentional gaps all along the torque tube. We introduce optionally all the DC wiring inside of the torque tube, and we increase a little bit the height of the tracker so that we can collect more reflected energy. With all these features, we can boost the bifacial generation, and we wanted to test it. We wanted to make sure that what we were saying was true. So we designed and built the first bifacial tracker evaluation center in 2018 in Livermore, California. 2 years later, now we have collected all the data, and we have assessed that data through independent engineers. And we have collaborated with NREL, we have collaborated with Black & Veatch, we have collaborated with many solar panel manufacturers. We have tested their panels in this beta test. And we came out with these numbers that I mentioned before, with a 15.7% higher yield with the 2P configuration bifacial panels, and in the SF7 tracker. That is for a high albedo. For a seasonal albedo, the numbers go lower, but still over 9 to 10%. So it was for us a great achievement to make sure that the numbers that we were sharing with the industry were right. After that, we have sold and built plants all over the world with more than 4 gigawatts installed worldwide in countries like Brazil, Mexico, or Spain. Here are a couple of pictures of it. But we have realized that the market is changing. Actually, the market is continuously changing. And the question is, if the SF7 bifacial tracker works, why launching a new tracker, right? Well, there's many things that are happening right now. And one of them is that the panels are getting bigger. Because of the panels are getting bigger, the structure needs to be heavier, needs to be reinforced. So the trackers are becoming more expensive, and it's not related with the configuration. One panel in portrait or 2 panels in portrait, both of them need adjustments. So the 2P trackers are going to need to get their rails and their torque tube reinforced. The 1P trackers are going to need to get their dampeners and other parts of the and also the rails reinforced. So it's something that is happening in the entire industry. Then there's another thing that is happening, and is that despite of the fact that we have been striving in showing the market of the benefits of the bifacial generation, still we can see that an experienced and ultra conservative simulations from advisors and EPC contractors end up minimizing the bifacial gain of the 2P tracker. So it's important to know how to model and simulate the bifacial trackers in order to get real numbers. But we are seeing that is not always happening in the market. So we needed to introduce improvements in the tracker that could reduce and optimize the cost. because despite of, as I said, this bifacial gain and the boost that is happening, sometimes is not considered, and very often so far it's not considered. So it's necessary to adjust the price. It is actually a real challenge, and because we have to get the best balance between reducing and optimizing the cost, but increasing or at least not reducing the quality, and by still providing the same service and delivery times that Soltech has been doing so far. That's why we introduced the SF7 Tandem, which is the first 2P link tracker in the market. We have seen other 1P link trackers in the market, but this is the one that is a 2 panels in portrait configuration tracker. It introduced other improvements, other advantages that my colleague Miguel Pozuelo is going to convey to you in a minute. I think we can, now my colleague can share the screen. I will stop mine and he will resume the presentation.
Thank you very much, Eduardo, for your presentation. And yeah, Miguel, now when you're ready, start sharing your screen. And just a reminder to everyone, so we will send you the presentation slides and the recording of this webinar by email early next week or towards the end of this week. Right, so and I can see that some people have already started posting the questions, but if you have a question, don't keep it to yourself. Post it on the Q&A box. Okay, so Miguel, would you like to start your presentation?
Sure, I will.
Thank you.
Thank you. I think it's very good to know where we come from in order to understand what challenges we are facing and why are we moving in this direction. No? So first of all, I would like to give a brief introduction of how the product is, how it is designed, and then go to the dilemma triangle that Eduardo was showing before. No? Like in terms of cost, of quality, and service, how this SF7 Tandem provides this equilibrium or this balance between these three components that are critical in this market in order to obtain the most competitive solution. So as you can see, if you're familiar with our trackers before, no, this product resembles the SF7 that we were working before, with a 2-portrait configuration, up to 3 strings, 7 piles. And the main difference that we are seeing is that we are moving both trackers with the same connecting cardon. Similarly to the dual row Eduardo was mentioning before. And this change is somehow quite different to the other ones in one portrait. No? We are going to see why this bring different improvements to the plant. So as you can see, we are moving with a single motor. We are moving 2 trackers, each tracker with 3 strings. So in total, 6 strings being moved by only 1 motor, and it uses 1 single track control. So as I was saying, we are going to analyze this SF7 Tandem from these 3 perspectives. No? In terms of cost effectiveness of the solution, from CAPEX and OPEX point of view. Also, we will cover quality. How can we provide the highest quality in this product, no? And bring the reliability that is required for a product that needs to be exposed during 25, 30 years. And finally, the service, no? How the SF7 Tandem and Soltech is behind this product to provide the best service from design to the O&M and during all the project phases. So to start with the cost effectiveness, I like to divide this in 3 parts. I don't really like, when talking to clients, I don't really like to analyze the CAPEX per tracker alone, because the tracker is a product that is designed for different conditions, but is dimensioned for each independent project. So it would not make sense to analyze the tracker itself in a bubble. No? We need to understand what's going around the tracker. So I will structure this part in three. First of all, I will talk about supply and installation. Secondly, I will go through the BOP related to a tracker, how the balance of the plant is affected by the selection, just by the selection of the tracker configuration, and how SF7 Tandem can improve the BOP cost. And third, about the maintenance, how 1M is affected by SF7 Tandem. So first of all, talking about supply and installation, what we can see in this configuration is that we are reducing compared to the traditional SF7. We have been putting in the market during the last almost 3 years. We have already supplied more than 6 giga. And we see that we have fewer parts. We have 50% of motors and 50% of track controls. This is something that no matter of the project location or the project characteristics, this will bring directly cost effectiveness to the project. Secondly, we have fewer components that come from the previous design, come from the SF7 tracker advantages, and the most important one of these is the lowest piles per megawatt. We are compared to a traditional 1P or a dual row 1P, we are lowering by 40 to 50% the number of piles, which has, we will see later, a very high impact in cost. And then we have 60% fewer screw connection in SF7 Tandem, and also 20% fewer parts. If we go to the impact related to the BOP, we see that there are a couple of activities during construction that are directly reduced, like pre-drilling and pile ramming activities. We are reducing the number of piles, therefore, we are reducing the number of pre-drilling and pile ramming points. And one important thing is, with this new configuration, there is no need of any additional pile or any additional element rather than the connecting cardan that joins both trackers. We will see later how it does and how it allows for easy integration in the plant. Then also it keeps high relation to terrain. I will go further in detail when talking about the quality brands, and reduction of civil works. As this tracker, SF7 Tandem, is very flexible and very adaptable and can be installed with very low civil works on site. And the third branch I wanted to mention is about the OPEX. Like, we keep being able to provide a face-to-face cleaning, as you can see in the image on top. And the trackers are linked, but it allows for cleaning 2 rows and 2 rows without needing to go in the middle of the connecting card. In any case, as you can see in the image below, the maintenance can be provided and movement can be done between these rows, because the height of the cardan is 1.8 meters. So vehicles can work and can circulate through the SF7 Tandem, which is an advantage that we cannot find in dual row 1P trackers, because of the lower height of these connecting rods. Also, regarding 1M, we are seeing that it's more and more common to find robot integration in these projects. So it's one of the things we have to bear in mind when designing SF7 Tandem, is to allow for easy integration of the robots. We are seeing, especially in Middle East market I'm focused on right now, is a key aspect that needs to be considered, and especially from an OPEX point of view, in terms of production, in terms of OPEX costs. And with the SF7 Tandem, we are able to provide wide tolerances. We are minimizing the cost of integration. We are reducing the number of robots that need to be included per megawatt, and avoiding interferences. One important case here, we are working with the key automotive clean robot suppliers worldwide, and one of the key aspects aspects here is the integration of the communication between robot to tracker in order to provide the safest and most reliable solution. So if we can, no, it comes to comparison. If we are seeing the SF7 Tandem, we want to understand what is the main difference against the 1P dual row that we have seen in the market for the last year. Here, I want to briefly show two different comparisons. No? First of all, is in terms of the number of components from SF7 Tandem to a dual row, 1P. And then I will move to a case study of 100 megawatt peak to understand the influence in cost that the selection of the tracker can cause in the project. Of course, this is a specific project, no? And as I said before, we have to analyze in depth every project to understand the real impact in cost. But it is important to know that this impact can be up to 10–15% of the tracker price. So first of all, we're going to the tracker. As we can see, we are comparing two SF7 Tandem. So we are talking about 4 tables, 12 strings with 3 dual row, 2 times 1 portrait 60 modes. No? So also 6 tables of 2 strings. So in total, 12 strings, 12 strings, in order to put in the same level of comparison. The number of piles for these 12 strings in SF7 Tandem will be 28 compared to 57. Is more than double that dual row would have. In terms of the number of torque tubes, we are also passing from 16, it's 4 per table in a SF7 Tandem, to 45 in the dual row. Torque tube joints, we also see here more hardware that is increasing the complexity, you know, and this will affect the installation of the tracker. The slewing drives, this is interesting. In the SF7 Tandem, we keep the slewing drive per row. We are not reducing any elements, so we can plug, and in terms of stability that we will see later, we can have the same behavior as we have with SF7, and we have experience, and we have proved during 3 years of expertise. Number of motors, 2 instead of 3, and the tracker controllers also are decreased by half, so we have 2 for this instead of the 3. Dampers, there's no need of dampers, as we will see later. Quality wind part, we will understand that the stability of the SF7 Tandem is achieved by robusticity of the components. There's no need of external elements that will include also additional points to cover in O&M, and also additional cost of spare parts and initial capex. Going through the second table, I know it's lots of numbers. I don't usually like to put this, but to have a rough idea, what we have done is in a 100 megawatt project. It was a case study in Mexico. We have analyzed the different BOP related to tracker elements. No? So a cable, the stream box to conversion unit cable, communication cable, ALS rods, solar area, DC trenching, AC trenching, pile ramming activities, and pre-drilling. We have considered 50% in this project. So when we analyze the numbers, no, on a layout with a dual row 1 portrait 60 and the SF7 Tandem 2x45, we can see that there are many differences. On the first 4 lines, there is a strong connection through the strategy when the layout is designed. It has been designed with the best strategy for dual row according to our criteria, and the best strategy for SF7 Tandem also according to our criteria. And in the last rows, we can see that it goes directly with the tracker design. If you see the impact only in pile ramming and pre-drilling activities, and we have a low cost per point because it's taken from Mexico, 10 USD per point for pile ramming, 15 USD per point for pre-drilling. We are seeing a difference of over 500,000, 652,000 USD, which is 0.6 cents USD per volt peak, which is, as I was saying, about 8% of the track price. So there is a strong impact on the SF7 Tandem, not just in the capex of the product itself, We cannot show here because it will depend on each project, no? So we cannot give, unfortunately, a figure, but it will have a strong impact on the BOP related to the tracker. If we move to the second branch, after talking about cost effectiveness, it's very good if we can come with a better product, cheaper product, simpler product. We need to see if this simple product is able to provide the warranties that is required in a solar project. By now, what we are seeing is the solar projects are located in extreme weather condition areas. Also, they need to be in operation with a higher availability during 25-30 years. So, of course, quality is a key item here, especially when we have seen this industry working for less than 10 years at very utility scale, and we need to design for 25 years. So there are few items of design that come as heritage of SF7. That is the self-stop. This is a very important aspect. That is the tracker. The SF7 Tandem tracker is able to position itself at stop 45-50 degrees stop angle when being installed. So when before commissioning, the tracker will be able to stand any dynamic wind effect that can happen. The surge protection device is also a solution that comes together with the design that avoids electrical impact on the electronics and other items in the tracker. And the tracker monitoring system is something we're quite proud of, that allows us to be before the client to foresee any impact that can be, and also to alarm in case of anything going wrong. As I was mentioning before, two drives, so we have 2 points of blocking tube in both tables. So this provides also for more robust and safer design. Regarding the tolerances, this is something quite important. When we see a tracker that has a connecting element, we tend to think that it will not be flexible, it will not be able to adapt to slopes or to different soil conditions, and it will directly impact in BOP cost civil works. In this case, what we can see is that we keep the 17% north-south slope SF7 has. We gain 25% east-west slope, and we have 8 degrees of misalignment from the trackers joined by a cardinal. This angle can be increased, can be analyzed, but with the standard dimensions of the tracker will be like this. We can always work on a specific solution for each project in case a higher misalignment is required. And the product has been tested for pitch up to 13 meters by now. When talking about tracker in the last years, of course, we need to talk about the wind. How has the tracker been dimensioned against dynamic wind effects? And I'm going to do similar to Eduardo. I'm going to go through the last year, how Soltech has been acting, reacting, and going to the cutting edge of the technology in terms of to understand how dynamic behavior was and to ensure that our clients could be safe with our design. So we started back in 2013, 2014 with static analysis, with analyzing the pressure coefficients in a rigid model, as you can see in the left side picture. We were able to obtain the different coefficient pressures in different lines, as you can see below of the image. But the problem with this methodology, and was the extended problem in the industry, is that it was considered the tracker as a static element when it's not. So we kept analyzing deeper. We joined forces with AWDI, Canadian consultancy, experts in wind design, and wind design for Burj Khalifa, Golden Gate, amongst other wind designs. And we started to analyze instability and aeroelastic modeling with a sectional model. That is the wind tunnel you can see in the middle of the image. We still were analyzing in 2D, but we could start to understand how the dynamics of the tracker were happening, and we were able to predict when instability could happen. So in the last 2 years, we have kept working in this direction with a fuller elastic wind model. Provides the difference between the right image and the left image is that we are working now with flexible models. The trackers are flexible, so the impact of a dynamic wind effect will impact the position of the tracker and will impact the wind received by the following rows. And we are combining this understanding together with a full PV plant CFD calibration. So we are able to bring these results of the full elastic model to a specific case. That is what we really want, to understand the specific situation of a PV plant and be able to provide a solution that can ensure that both us and our clients can be safe, can be calm during the entire life of the PV. If we compare again how the design of the SF7 Tandem and the 1P dual road tracker compare, and what we have done here is we have separated one branch of the SF7 Tandem to understand how it impacts in the design. And as we were saying, we have much fewer components. I would not be safe if these fewer components were the same thickness, the same quality of other items. We would be missing something. So the way that SF7 Tandem has evolved has been by reinforcing the critical elements of the tracker to provide this frequency stable solution. So the main components, we are working with very robust piles, WU 810 to 821 generally. These piles are thicker, they are symmetric, so also they behave extremely well and, with very hard soils. They allow many times to also reduce pre-drilling operation. Then we have introduced the rotation bashes of simple piles that are regulated by the torque to frictional stress. We have increased the thickness and the profiles for the mounting rails. We have also increased the robusticity of the slip wind drive connection with the internal torque tubes, and also we have improved the design of the section coupler between different tubes. So this way, we don't need to add any, as commented before, any external element that will require high attention or will increase the cost of the tracker. If we compare in numbers, we can see below on top we have 8 tubes for SF7 Tandem, 4 in one side, 4 in the other side, compared to the image below where we have there are 8 plus 7, so 15 tubes. Also the number of piles that we mentioned before. So we are achieving, what I want to say here is that we are achieving this robustness or this stability or this behavior by increasing the thickness of the profile. So this is why the price of the 2P tracker is not way lower than the 1P. This is the balance. And finally, the third aspect, I will go very quick on this one, the time and service. How is the SF7 Tandem balancing this third branch of the triangle, this third vortex? So in terms of services, at Soltech we are very proud to be able to provide on-site services. This is in the NDA of the company since its creation. And at Soltech, the tracker expertise is shared with the client during all the phases from design, the pull-out test, construction, and the installation services of construction and O&M, and then we have also the Soulmate, which is the customer service that we have after the plant installation. So all these phases are covered, and with the SF7 Tandem, we keep in the same line, and also we keep with optimized O&M cost. The second point, Soltech solutions. We are not happy with providing a tracker that can adapt to the market. What we are trying to do is create, innovate, and bring solutions that can automate the installation of the plants, that can make plants simpler, can make installation quicker, can, at the end of the day, that can make our clients be more competitive in the market. So we have come in the last years with a DC harness solution for plug and play connection, the stream runner, for in-tube cable management, that also reduces the BOP cost related to tracker and trenching. And the team track, I saw one question related to team track before, so I'm going to answer. It was how SF7 Tandem deals with a team track algorithm. It's a very good question, actually. So to understand this, we need to know that team track takes as inputs all the topographical points of the different trackers after the installation. So basically, there is a knowledge in the tracker monitoring system of the entire plant and the geometry of the plant. And based on this, and based on weather data, the trackers are acting in a way that maximizes production. In this case, the team track will act in the same way. The only difference will be that the tracker will not act independently. Each tracker will not have different angle, but it will be every 2 trackers. So it's the same philosophy, but the tracking angle will be every 2 trackers. There is a specific algorithm that takes this into account. And finally, it's important with delivery and good support during the logistic and the supply of the trackers. For this, Soltech has a Sol Hub network of different logistics centers around the globe, both where our manufacturing facilities and in the main countries we are operating, to provide quick assistance during the supply and also during the O&M life of the project. One important thing from the 11 gigavolts that Eduardo was mentioning at the beginning, we have installed with our own team more than half, 5.6 plus gigavolts. So this gives us a very good input on how to design, and this input of design is the one that we have used in order to deal with these 3 branches. To deal with the cost effectiveness, we are able to provide an SF7 Tandem solution that provides lower capex because of lower number of motors and track controllers, and lower OPEX because lower motor consumption, lower parts, and better robot clean integration. We are keeping the highest quality standard, designing against the wind, and boosting bifacial deal. As Eduardo was mentioning, we are keeping the structural design that allows for an increase of 2.1% compared to traditional one-peak trackers, are not bifacial trackers because of the shading nature. And third and last, the service. SF7 Tandem is full service from design phase, supply, during installation, and O&M, with solutions to optimize in all these phases. So well, I now have time for questions and answers, and I hope you have enjoyed the presentation and you can enjoy some of this product in your plans.
Thank you very much, Miguel, for your presentation. Could you please stop sharing your screen so
Sure.
Everyone can see us during the discussion? And right, so we have a number of questions here. I've seen also that Eduardo has been very active in answering them. So in essence, I think that this you have explained how the 2P tracker provides better performance and is more cost effective. Is that always the case, or are there cases where it's better to use a 1P solution or a different tracker depending on solar resources, the kind of panel you're using, and other conditions?
Would you like to answer, or Miguel, or do it myself?
I'm happy to answer that one. Yeah, basically there are two key items that affect the cost of the tracker in one project. The first of them is the maximum wind speed that we find in the project, and the second is the soil characteristics. These two can produce a very high impact going for one to other solution. So I would say, yes, you're right that in some project locations it can make sense to go for lower width tracker. No, in 1P tracker it would make sense at very extreme weather locations, no, over 180 to 100 kilometers per hour. And in those locations, the wind impact will be lower in the dimensioning of the tracker. So whereas in an SF7 Tandem, the tracker will require to increase to very high thicknesses and going to lower number of stream per tracker. In the 1P tracker, the effect will be smoother. It will reduce, but at higher wind speeds. In those projects, it might make sense also to go for other solution different than tracker. And then regarding the soil, the main impact, we can see that the higher the undulations, no, the worse topography of the project, and the higher the how to say, like the hardness of the soil, like complicated soil, the 2P will take a lead on the 1P. For very easy soils, very flat terrains, and no need of pre-drilling of a micro concrete foundation, in those the difference will be low. So of course, it's very important to analyze project by project and see. But in a general case, I would say, like in most of the locations, especially in the markets we are more focused on, like in North America, Latam, Middle East, Europe, and Australia, we are seeing that in about 90% of the projects, we are getting this very cost-effectiveness solution. And Eduardo, if you want to add anything on that.
No, I'm okay with the answer. Thanks.
Great. So another question, which I think I've seen quite a number of questions regarding the installation of these trackers. Are there any special considerations when you're actually setting up and installing the tracker?
Yeah, well, typically because this tracker is higher, people tends to think that it's more expensive to install and that you might need ladders to install it or to install the panels, and it will be more expensive and it will take more time to install the tracker, but that is not right. Because the tracker is a moving structure, it can be moved up to a man height position, so you can install the panels at the same height as in a 1P tracker. Then you would move the tracker into the opposite direction and you would do exactly the same thing. When it comes to the parts of the trackers, this 2P configuration has around 20% less parts count, 46% less piles, which is almost the half, and around 65% less screw connections, which makes the tracker very fast to be very quick to be installed. And it's true that there's, especially in bifacial trackers that are a little bit taller than the regular monofacial tracker, it is true that there's some regulation parts on top of the piles that for short men it can be necessary to use a little stool of around half a meter, and they are made of plastic. They're very easy to transport and move all across the site. But it's true that it can be necessary for them to do it, you know, to tighten the screws and the bolts. It would be easier for them to use these tools. For high men, like I don't know, like 1.8 meters tall or so, it's not that necessary. Take into account that the best part of the solar plants that we have supplied, it has been in Latin America, and Chile, Brazil, Peru, Colombia, where, and even Mexico, where the average height of installers is not. I mean, they're not just normally they're not tall men, and they could do it at very good installation rates. So I think it's important to take that into account.
Okay, thank you very much, Eduardo. And there is a question here which I think is interesting, which is what are the typical distances between rows considering the linking bar?
Yeah, well, it depends on the GCR. With the linking bar, there's no variation in comparison with any other independent row tracker. You can install trackers at, I don't know, 7 meters pitch, from 7 meters pitch up to 13, 15 meters. It's true that there's a certain moment in which it's normally anti-economic to do it, because you would need a very large surface, and even though you are increasing the yield of the plant because of having a better GCR, smaller GCR, is counterproductive. So typically the GCR is between 30% to 40%, let's say, which makes the rows within the range that I've mentioned. This system, this tandem SF7 version, is it prepared for this average GCRs? It is designed for that.
Okay, and well, regarding also O&M, I've seen quite a lot of questions regarding O&M, the kind of robots that could be used, the kind of cleaning protocols, whether there are any particular things to take into account in case that you use a 2P tracker of the kind you're talking about. So I know that you have answered most of these questions, but could you reiterate what are the main things to take into account when it comes to the O&M aspect of working in a plant that has a tracker, that 2P tracker?
You can answer that one, Miguel. You wish?
Can you rephrase? I was replying to one question.
Right. So it's about.
Again, I appreciate it.
Yeah, no problem. Yeah, I can reiterate. So it's about operations and maintenance. So there have been quite a lot of questions on O&M and how O&M protocols, or like the robots you employed, and vary if you use this type of tracker. So could you reiterate the main points to take into account?
Okay, in terms of O&M, there is one that comes directly with the design. That is the fewer number of electronic components. No? So we have half motors, half tracker controllers. So just because of that, we are reducing the O&M activities. No? We are including moving cardan. No? That will need to be taken in consideration, but the rate of failure will be much lower than the one that could expect from an electronic component. In terms of robotic integration, and it will be very similar. The point I would like to highlight, that I didn't mention before, is that when we are talking about robots, we have different types of robots. The ones that move on top of the tracker at 0 degrees and do not need to go through the rails, and the ones that go through the frames in both sides of the tracker. So there is one that comes like the typical Roomba that we have in the household, like the Ecopia format, that would move from one tracker to the next one through a bridge in the middle of the tracker. However, the other ones are getting also very common in the market. Will have an impact of any linking rod or any cardan if the solution is not designed against this. I don't know if I make myself explain, but when the tracker is facing the cardan or the linking rod, there will be an obstruction to the robot that needs to be taken into account, and it needs good communication between the robot and the tracker. Also, one aspect, in order to optimize the number of robots in a plant, it's very important to, when designing a layout, get the maximum number of trackers in north-south direction. So one robot can clean up to 16, 32 trackers, no, in very large plants. With the SF7 Tandem tracker, the good thing is that by having the cardan at 1.8 meters, there is access to the middle of the two tables to do harvesting, to do any O&M activity. So you can keep installing the trackers in a long north to south row. With dual row trackers on P that have a barrier, you need to leave access from the north or from the south in order to be able to provide O&M in that interior part. So it will have worse consequences in terms of the number of robots, or it can avoid the use of fully automated robotic cleaning. So summarizing, in terms of paths compared to SF7 normal tracker without tandem, we are reducing the number of track controllers and motors. The consumption per unit of the motor will be higher, but anyways, we are reducing the total consumption by about 20%. And in terms of robotic cleaning, it's fully adaptive, so it will have no big impact, and it will be a better solution compared to a dual row 1P tracker.
Thank you very much, Miguel. We were losing you a little bit towards the end of your answer, but I think we got like 99% of it, so that's good news. I think.
Apologies for that.
Yeah, that's okay. So we have a question regarding the most common kind of foundations used for the trackers in the Middle East. So would you like to answer that question?
Yes, the most common solution, it depends a lot on the specific site. In the Middle East, we have many different locations, but what we are seeing as a general rule is that in many projects we are finding very hard soil. So there are dunes that at a very low depth we find hard terrain. So in these cases, there are different solutions. No? Generally, the way we approach it and the way we have analyzed up to date is that we can go with a very high percentage of direct pile ramming because of the nature of our piles. No? The symmetric pile, thick piles, no? They are like 4 or 5 millimeters thick. They can break this hard soil, and there's no need of a different foundation type that could be pre-drilling plus pile ramming or a concrete foundation. Also, we are seeing that in many projects the soil is very heterogeneous. It's not similar from one part to the other of the project, and there are also important aspects regarding soil corrosion that need to be analyzed. In this case, we can find different solutions. Generally, it can be a combination of either using concrete or using epoxy. But in general lines, I see high percentage of pile ramming with another percentage that can range from 0 to 50% of pre-drilling for our solution.
Right. Well, thank you very much, Miguel, for your answer. I think that unfortunately, we're kind of coming to an end of a webinar, really. So I know there are a few questions left there. So we'll send those to you, Miguel, and Eduardo, and then if you'd like to answer them, then you obviously can in your own time. But now, well, since we're coming towards the end of the webinar, would you like to do you have any parting words for the audience? Eduardo, you sound like you want to start. Go ahead. Oh, we can't hear you. You're on mute.
Sorry.
Yeah.
I thought I was unmuted and I did the opposite. All right. So Well, I think that in our presentation, we highlighted 3 points that we think that are paramount for the SF7 Tandem. One is related with cost, and I think that is the most important one that we want to convey here. The SF7 Tandem is it's true, it's cheaper because it has less parts, but it doesn't change anything in terms of robustness, in terms of adaptability, in terms of, I don't know, high technology that it includes. So we have designed it and made it for preserving all the advantages of the SF7, but incorporating more cost-effective solution. Then there's a second one that is related with quality. We wanted the tracker to be exactly as much as similar to the SF7 in terms of quality. So the only thing that we changed, the only thing that we implemented was this cardan shaft. And for the rest of it, it's exactly the same, meaning that the motors, that the controllers, the rest of the parts that in which we have a lot of experience, it remains, it's exactly the same. And then for the service, we wanted the tracker to be as much factory serviced and taking or being or putting the highlight over on the maintenance, on the maintenance cost. So we didn't want that the tracker, because just because it has a tandem, it has a kind of a shaft that blocks every 2 rows, the aisle every 2 rows, could be more expensive to maintain and operate. So that's the reason why we put the cardan shaft at the 1.8 meter stall, so that the maintenance service vehicles can go through and without interfering with that. And also for the face-to-face cleaning or the robots, it doesn't interfere either. That was actually one of the questions that I responded. That was, how could a robot clean the solar panels if they have the shaft? Well, the answer is because depending on the design of the robot, some robots can clean at low tilts. So it's not necessary to go to a 45 or 60 degrees tilt to clean. They can clean at 30, 20, 15 degrees, and it's fair enough for them. And still, this robot can pass through the shaft without interfering with it. Take into account that the torque tube is at a higher level than the motor. The motor is maybe 20, 25 centimeters lower. I'm not sure how much is it. Maybe it's 1 foot, but it's more or less like that. So it gives the chance for the panels to get tilted a little bit without interfering with the robot or with any other element of the tracker. Also, the shaft doesn't. It's not that it doesn't cast a shade in the panel. It does, but it's negligible, because it's just in a few certain moments in the morning and in the evening during the year. So it's not every day. It's not every time. It's just, so if we made simulations and it's almost negligible. So we can share those simulations with you, so that you can see that interference is almost nothing in terms of front side generation.
Thank you very much, Eduardo, for your answer. Miguel, I don't know if you want to have if you have any final words for the audience.
Yeah, well, I want to highlight the part of the experience. No, it's not. I think it's very good to understand that it's a new product that has been adapted to the current conditions of the market, to the request of our clients. And the good thing is that it's not completely new technology that needs to be proved. This technology has been proved through the last years, that has been tested, has been very well analyzed. So I think this gives confidence, no, and reliability that it's a technology that can be trusted. That's the most important thing.
Well, on that note, we are about to finish the webinar, but before that, I'd like to thank everyone in the audience for being here. I'd like to thank both of you as well, Miguel and Eduardo, for your presentations. So to everyone who's still watching us, you know that if you like this kind of webinar, you can find more on our website, atainsights.com. So, well, without any further ado, really, let's leave it at this today. Thank you very much for being here, and see you here next time.
Thank you.